The 17th of July 2025, and it's haybob. It's vintage time. I'm trying to make the gate for a haybob, but one of the things I want to show you here is I have brazed on. Do you see it here? I brazed on my tips using bronze solder, not any silver solder, because silver solder is expensive and it shouldn't really be used except in very exacting situations. And you're putting silver into something and it'll eventually be thrown out. So brass and bronze does the job quite well. So I'm just trying it here. Do you see it there now where I bronzed it on? Now, this is not strictly speaking turning between centres. This is an old tractor bolt or implement attachment bolt, and it's made of pretty good steel, but I needed pretty good steel, and I need to bring it down to roughly 25.5 millimetre. And so a big old rough lump of carbide will do the job, and I'll be buying them at 68 cents for a box. So that's one, and I don't have the other. The other one's badly damaged, so I'm trying to make that, and that there is the fit of that. It's roughly it's 25.5 roughly an inch, and so I want to replicate that. But if I get it up to there and weld it onto a piece of 2B1, the rest will be all right. Now I got these in the Variety Mart. They're of a man called Jeff. And he attends a lot of these things. Very good man. I don't get anything off him for telling you that. So if you see here, folks, I have to hold the camera. That there is 60 degrees. Wait until I get a better grip. See, I can't. I'm using the camera to see it. There's a delay, you see. So it's 60 degrees. See? So this is a thread pitch gauge, 60 degree thread pitch gauge. UNF, UNC and metric are all 60 degrees. And so is BA, but the width is 55. So that'd work perfectly for cutting threads. In fact, I should keep it, but I'll get a few more of them. So that would be an ideal setup for cutting threads on the lathe, and I won't be doing that today. So we're going to continue a bit. So I've turned it around. I'm after also brazing this one onto this as well. That's rough. Broke it off straight away. So the tip came off, and I'm not surprised, for I didn't use proper degreasing. I just brazed it as an afterthought, and that proves there was grease on it. It wasn't a good joint. I expect this joint to be a lot better. I degreased this and did it according to the book. Now, tungsten carbide is great material. It's very brittle. Now, I don't bring it back. I pull it out before I bring it back because you could easily clip the edges off it. It's very hard material, but it's also very brittle. So we check it again here. I can take plenty more. I'm going to take a few more cuts. Now, this setup is not turning between centres. This is just supported turning. When you turn between centres, you have a faceplate and you have a driver to drive the shaft. It's drilled on both ends like this. It's set up like this, but not at this end. If there's any out alignment of this piece of steel, it's going to impose pressure on the jaws of the chuck and possibly damage it. The other thing, even with this setup, you couldn't turn at that amount of overhang. The way that is there is overhang. You can't have that amount of overhang. That's going to flex. So you support it here with the live center. You see, this can go around. You support it. But when you're doing that, you want to keep checking the wheel with your hand to make sure it's tight. You want to make sure, even though you tighten all these here, you want to keep a bit of pressure on it with your hand. Because as that gets loose, you allow wobble, and you do not want wobble. So we're going to go again. Now that's staying on for now anyway. It's well brazed. I knew by it was well brazed. Cleaned and got right. The other one wasn't. It was really an experiment. Keep checking your wheel that it's tight. So I'll shut it off just to save time. Now I'm using a thick soluble oil, and I had a little squirter and it got lost somewhere. It's there somewhere, but I pour it on it. And by right, the soluble oil keeps the temperature down. Where there's high speed, you need a coolant. So I'm putting it on by hand. I have an automatic system here, but the motor's gone and I have to get that. So one of the things of this, it'll skite out red hot steel, and if that gets in your eye, it'll damage your eye. So always wear some type of protection. These are what the market offers, and you can get full facial ones. I have one of them too, but I don't always have them just here. But these ones then can be put down then for brazing. You see there's a flap on them. Anyway, don't let your eyes be in danger. I've often got, even wearing those glasses, got burnt on the cheeks. Now most of the new lathes have a protection. You can't do that with them. They have a thing round here. They can be a bit of a nuisance. Some of them won't work without it, but do not risk the eye. There's very, very high temperatures involved, especially where you have tungsten carbide. So we're going the best here anyway. Straight away you see the heat. And bring it back while it's still running. Don't run it dry against the work. Now, I don't need exact dimensions, but I need them fairly exact. So we'll take a slice now, and when it gets started, I'll switch off and come back to you later. Now we're coming quite close. I've just measured there. I only need to take another bit off. The brazed tip, you see, you can get a screw and a mechanical tip, which means they have to be punctured with a hole in the centre, the carbide head. But I'm getting more excited about this patent. Now, this was designed, I think, and patented by Iscar, ISCR, in Israel, would you believe? The first of these I ever saw was Iscar. I used to buy them. And they brazed them onto a piece of excellent steel. Yeah, there's one there. And there's no reason that one now come a cropper. But that's actually good steel in itself. If you harden and temper this, it will actually cut on its own. But I'll be keeping those and using them then to re-add my stuff, Iscar. Now, funny enough, the famous investor Warren Buffett, he said that Iscar, he invested in, he said it was a great industry. Well, I don't know whether it is or not, or how it's going, but he invested heavily in the machine tools for Iscar that makes these. I remember reading that in the paper. Right, we'll see, we'll not hang up yet, we'll finish the work. So I've reached my target of diameter, and you see the tiny hole in the end of it. I drilled that, that's hard. But isn't it funny, I have a funny feeling that the bars and the bolts and the attachment hitch things and pins for mechanical, for farm machinery are only hardened on the outside. I noticed this when I took the first cut, it seemed to get softer. They're only hardened, I think, on the outside, but we'll do more experiments on that at another time. So now you see, I have to take off this collar here, and then I have to decide what length. There's a reduced diameter then that goes up into the other prong on the mower. On the rake, should I say. And by the way, if I did happen to say, I was just thinking there, tread pitch gauge for this. That's a tread pitch gauge. I may have said a dial test indicator by mistake. No, it's a tread pitch gauge, okay. So there's the result. The shiny one is the new one, reduced down in size. I'll be cutting off this piece here, see that there, and then we leave that up there and reduce it down at this height to this diameter here, you see, to replicate the same thing. So I'll take the final cut and I'll leave it a bit too much in, because I'll take it and try it on the haybob. Now this here has to be cut off and cut off there. That can be really just done with an angle grind. There's no need to use precision equipment. And then this will be cut off here as well to replicate the part I'm trying to make. But always leave more in. It's easier taking it off than putting it back on, and I'll have to check to see what diameter I get away with back on the machine itself. All this type of work involves the removal of metal. All machining involves the removal of metal, or indeed wood it could be. So you don't try to get the length right and all that at the start. You get your diameters right, you get your critical dimensions right. It's easy whipping this off this, easy, and it's not going to be decorative, so it doesn't really matter. And it's easy cutting this to the right length. So get your diameter right, and then you can come along then and trim it to whatever size you need. And you have to be practical. A haybob is not exactly a precision equipment. The gears are the only thing that's precision. But one of the things about it is that is this tip, how well that tip stuck it. It really stuck it well. And this whole idea of brazing them on now seems to be very effective, provided you do it properly. I think we leave it like that. I might, before I quit, cut off that bit there, or I might not. I'd like to know what that material is. Will it harden right through? Is it tool steel? Or is it some other type of steel? There certainly is an outer crust. I have a funny feeling it's mild steel, and it's dipped in what do you call it, carbon, and given a case hardening, which would be the cheapest and best option. I'd say that's what it is. Perfectly adequate for all the farming needs and all the tractors and everything. So right, folks, I hope some of you enjoyed that, and I hope to God, I should have said at the beginning, if you're not into this, don't look at it. There's plenty of other stuff. Good luck. The Shenhua lathe, we have a lathe, and needs a bit of a tidying up. So we'll see you back soon, and we'll see now when I just bring it over. So there you are. See, I decided to trim it up, so I'll put a slight bevel on it. That's the job done. Now, switch it off.